Hey guys, just wanted to give a video walkthrough of our first pre-geometry summer packet. These packets all contain problems that hit on really important skills and concepts that we learned in algebra that are going to come up again in geometry. So what we'd like you to do is complete these packets about one every week over the summer just to keep these skills and concepts fresh in our mind so that when they come up again in geometry, we're ready to go. And so for this one, I'm going to give you a walkthrough of each of these types of problems so that if you find yourself stuck later on, you can always refer back to this for help. So our first question here hits on the concept of solving linear equations. This one involves some distribution right here. We're going to have to collect some like terms. So let's jump right in. The first thing I think I'm going to do is I'm going to distribute this -6 over that set of parentheses. So -6 times x is -6x. -6 times +3 is -18. And the rest will stay the same for right now. One thing I like to do is when I see that I have two like terms on the same side of the equation, I just like to combine them so I have a little less going on. So we have -1x minus 18 equals -2 times x minus 16. I'm going to go ahead and add 2x to both sides of the equation, plus 2x. Nicely over here, these two are going to add to 0, so we don't have that anymore. That's nice. -x plus 2x is positive 1x minus 18 equals -16. And then I'm going to go ahead and add 18 to both sides. And we will have isolated our variable x, and we get x equals 2. Fantastic. Note, I'm going to do a little side example here. It's also possible that in this last step, instead of having a nice 1x, we might have something like, 5 times x equals 9, or something like that. In which case, in that last step, we would divide by 5. And you might end up with a fraction, but that's okay. One thing I like to do is when I have my candidate for a solution, I like to substitute it back in and make sure it actually works. So if x is 2, 2 plus 3 is 5, -6 times 5 is -30, -30 plus, this would be 10, -30 plus 10 is -20. Let's see if the right-hand side will be -20. -2 times +2 is -4, -4 minus 16 is -20. Fantastic, it works. 2 is the solution to that equation. All right, the next problems we're going to look at involve solving what's called systems of equations, where we have two equations that we're trying to solve at the same time. Now, these equations have x's and y's in them. So we're looking for an xy pair, a value for x and a value for y, so that if we substitute them into these equations, it makes both true at the same time. Now, one thing I really like here is that we have a statement that's y equals already. So we know that this y right here equals -7x plus 8, which means that this y right here should also equal -7x plus 8. I'm going to substitute this expression right here in for that y. Check it out. So I'm just going to kind of bring on down. So we have -2x plus 6 times the quantity of, and here I'm going to go ahead and substitute -7x plus 8. Substituted this in for that y equals 4. Great, now we have an equation with all x's. Let's go ahead and do it. So we've got -2x plus, let's distribute, so -42x, and then plus 48 equals 4. Let's combine these guys together. Let's see, -44x plus 48 is equal to 4. We'll subtract 48 from both sides, yielding -44x equals -44. Oh, fantastic. That means x must be equal to +1. So we found our x value. Woohoo! All we need to do now is we can take this x value and substitute it into either of these two original equations, and regardless of which one we do, we should find the same y value. Let's take this one right here. So we know that y is equal to -7x plus 8. However, we know that the x value is going to be 1. So let's see, y equals -7 plus 8. Oh, looks like y is equal to 1 as well. So it appears that our solution to this system of equations is the ordered pair 1, 1. What I like to do is always check, and I like to check with the equation other than the one I just used to find y. So let's try it here. -2 times 1 is -2, plus 6 times 1, -2 plus 6 is 4. Amazing, we're good to go. Okay, now that one was nice because we had a nice y equals just given to us right off the bat. In our next example, that is not the case. But one thing I do like about this example is that we have our nice x's and y's in nice columns. I would say both of these equations are in standard form. What I'm going to do is I'm going to go ahead and multiply both sides of this top equation by 5 and both sides of this bottom equation by 4. And you'll see why momentarily. So that top equation, I think, is going to become 20x plus 30y equals 90. The bottom equation is going to become negative 20x minus 32y equals negative 96. And what's so nice about that is what I'm going to do is I'm going to, you could say, add these equations together. I'm basically taking this equation up top and I'm adding the same number to both sides, right? Because that's something you can do. On the right-hand side, I'm going to add negative 96. On the left-hand side, I'm going to add something that is totally equal to negative 96, and that's okay. And what's so nice about that is when you add positive 20x and negative 20x, they add to 0. We're not going to have any x's anymore. And so that's why I multiply by positive 5 and positive 4 here to obtain a situation where our x terms we're going to add to 0 or cancel out. All right, so what do we end up with? Positive 30y plus negative 32y. I think we end up with negative 2 times y equals, let's see, negative 6. All right, one step, dividing by negative 2. It appears that we have found our y value to be positive 3. Awesome. Now what we're going to do is we can substitute that into either of our original equations to find our x value. So we know that 4 times x plus 6 times y is 3 though, is equal to 18. So we have 4x plus 18 equals 18. Oh, wow. When we subtract 18 from both sides, we end up with 4x equals 0. And I ask you, what number multiplied by 4 will give 0? Yeah, x has to equal 0. So it appears to me that our solution in this case is the ordered pair 0, 3. I'm going to go ahead and check it in this equation right here, because I already used this one to find x. So let's see, negative 5 times 0 is 0. Minus 8 times 3, that definitely equals 24. Boom, that solution checks out. So that's how you solve that sort of system of equations. All right, moving on to questions number 4 and 5, which each involve graphing lines. And when I'm asked to graph a line, or that is graph all of the xy pairs that make an equation like this one true, what I like to do is I do like to put this into y equals form. So I'm going to quickly rewrite it out here. 5x plus 4y equals negative 4. Let me make sure that's the right equation. Yes. Okay, so I'm going to go ahead and I'm going to put it into y equals form. First thing I'm going to do is subtract 5x. So we've got now y equals negative 4 minus 5 times x. Excuse me, 4y equals negative 4 minus 5 times x. Pardon me. I'm going to, you could say dividing both sides by 4, or equivalently, I'm going to multiply both sides of this equation by 1/4. All right, the left-hand side, I'm going to conveniently get y. That's wonderful. On the right-hand side, 1/4 times negative 4 is going to be negative 1, and minus 5/4 times x. Okay, some people often see this as y equals negative 5/4 times x minus 1. Either of these are fine. It's all about interpreting what it means. In this case, I think that this negative 1, that is going to be our y-intercept of the graph. It's the value of y when x is equal to 0. And that shouldn't be surprising, right? If x is equal to 0, this will all multiply to 0. Same here. So negative 1 is our y-intercept right here. Fantastic. And negative 5/4, that is going to be the slope of this line. And there's a lot of different ways to talk about slope. So I'd say our slope is negative 5/4. And that is, the way I like to think of it, is the change in y over the change in x. Some people like to call it rise over run. That's totally fine. And so what I would say is from our initial starting point, our y-intercept right there, for a positive 4-unit change in x, there's going to be a negative 5-unit change in y. So we're going to have another ordered pair right here. And that is going to extrapolate in both directions. So I will kind of do that exact same sequence in the other direction as well. And we end up with another point out here. And now we've got 3 points on our line. We know that it's going to have infinitely many points, but let's go ahead and connect just those ones for now. All right, fantastic. And here's our line. It comprises the infinitely many xy ordered pairs that will make this equation true. All right. Always remember to put those little arrows on the ends, meaning that this line goes on forever. So similarly, in question number 5, very similar, we're going to isolate y. This is actually going to be a pretty quick exercise. And when you isolate y, you end up with y equals, let's see, 4 plus 4 times x. So all right, here is our y-intercept here, 4. And the positive 4x, that is going to be our slope, meaning that our change in y, our change in x, or you can say the rise over run, if you will, is going to be equal to 4 over 1, right? This is a fraction way to write 4. So that means that our y value is going to go up 4 for every 1 unit our x value increases. So this is kind of off the graph, so we're kind of just guessing that one. But we could go in reverse as well. There's another point, and then here's another point down here. I like to get as many points as I can count out before connecting. I think it makes everything a little bit more accurate. So let's go ahead and let's connect those dots. Fantastic, and that is what this line will look like. All right, moving on. Now we're looking at some polynomial equations that we are going to solve by factoring. So it's really important that we remember all of our factoring skills from algebra. So in this case, I see that we have an n squared term. We have a 1n squared. And so I know that it's going to factor as n plus some number times n plus some number. Maybe these numbers will be positive, maybe they'll be negative, who knows. I do know that these two numbers are going to need to multiply to give negative 48. So I think our options are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And we need one to be positive and one to be negative, so that our product is negative 48. And they're going to need to add to negative 2. So I'm thinking negative 8 and positive 6. So we're going to say that factors as n minus 8 times n plus 6. And I urge you to go ahead and multiply these together to confirm that. Equals 0. And then we use the zero product property to say, listen, if this times that equals 0, then either this has to equal 0, in which case n is equal to 8, or that has to equal 0, in which case n is equal to negative 6. So our two solutions to this equation are positive 8 and negative 6. The general idea is get 0 on one hand side of the equation, factor, use the zero product property. Okay, next one. Very similar, just the one difference is we don't have 0 on one side of the equation. Let's make it 0. So let's subtract 5 from both sides, and now it's going to look the same as the other one. So p squared minus 3p plus 2 equals 0. Again, we've got a nice 1p squared, so we know this is going to factor as p plus some number, p plus some number. We know that these two numbers are going to need to multiply to positive 2. So it's either positive 1 and positive 2 or negative 1 and negative 2. Since they're going to need to add to negative 3, it's going to be negative 1 and negative 2. So p minus 1 times p minus 2 equals 0. And in order for this grouping to be equal to 0, p equals 1 or p equals 2. So those are the two solutions to this equation. And you could go ahead and substitute in 1 or 2 for p, and it'll make this equation true. Okay. Our next one, very similar. We just need to do one step of manipulation before we'll have one side equaling 0. In this case, now we have m squared plus 4 times m minus 32 equals 0. Remember, always a good idea to put our polynomial in standard form, meaning going from the highest exponent down to the lowest exponent. It really helps with factoring. This is going to factor as m plus 8 times the quantity of m minus 4 equaling 0. So m is going to equal negative 8, or m will equal positive 4. Fantastic. And our last one. This one is going to be significantly tougher. Why? Because when we obtain a 0 on one side of the equation, we end up with a trinomial whose leading coefficient is not 1. So this has a lot more different ways that we can factor it. Some people use what's called the AC method or the splitting method. Some people use a little bit more guess and check. You're welcome to use guess and check, in which case you kind of just know that you've got something times b plus a number, something times b plus a number, and you just need these two to multiply to give 3, and you need these two to multiply to give negative 16, and then you just kind of do a guessing and checking and making sure it all works out. If you're good with that, hats off to you, well done. I'm going to show the AC method, or the splitting method. So what we do here is, when we see that this leading coefficient is not 1, I'm going to multiply 3 by negative 16, that gives negative 48, and that's going to be a kind of special number. Its factor pairs are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And we're looking for a factor pair of negative 48, so one of these will be positive, one will be negative, who add to negative 8. So I'm thinking if we did a negative 12 and a positive 4. So what I'm going to do is I'm going to rewrite this, not going to do a lot, but instead of writing negative 8b, I'm going to write negative 12b plus 4b. And what's so nice about that is that now we can factor this polynomial using a strategy known as grouping. So I group the first two terms into one set of parentheses. I group the second two terms into another set of parentheses. I'm going to look for common factors here. So a common factor in this first grouping, I think, is 3b times the quantity of b minus 4. And a common factor in the second grouping, I think, is 4 times the quantity of b minus 4. And now we can write this as 3b plus 4 times the quantity of b minus 4 equaling 0. Amazing. Now we're in a position where all we have to do is find the b value that makes this grouping equal to 0 or this grouping. Our easy solution is going to be that b could equal 4, but it also could be the case that b equals negative 4/3. And those are the two solutions to this equation right here. So those are a lot of our polynomial factoring skills being reviewed in that section. Now I want to take a look at some radicals. The square root of 12 is lovely, but if we want to simplify that, remember that we can simplify radicals by factoring them. Right? The square root of something times the square root of something, as long as they equal 12. And what I'm going to try to do is see if I can make this factor right here a number that goes into 12, but a number that's also a perfect square. So I'm thinking a really good candidate is 4. The square root of 4 times the square root of 3. And the square root of 4, well, that's just 2. So I would say that the simplified version of the square root of 12 is 2 times the square root of 3. All right, same idea over here. There just happens to be this 5 out front. That's no big deal. Let's see, are there factors of 24 that are perfect squares? Well, again, I think 4 works. So we've got 5 times 2 times the square root of 6, because the square root of 4 is 2. 10 times the square root of 6, amazing. And we're done. Okay, here we have a situation in which our denominator is an irrational number. The square root of 3, we don't like that. So what we'd like to do is somehow find an equivalent fraction. We're going to do some steps, and we're going to come up with an equivalent fraction here whose denominator is a nicer number, right? Like 8 or 17 or anything other than the square root of something. So let's see. What we can do here is we're going to multiply this by a fraction having the same numerator and same denominator, because then that's just going to make this equal to 1, and that's okay. We're going to multiply by the square root of 3 over the square root of 3, because by definition, the square root of 3 times the square root of 3 is 3. And so our denominator becomes 3, and I would say that this is considered a simplified version of that fraction. All right, so in general, if you have a square root down here, one strategy is to just multiply by itself, and that'll clear that, or it'll make that denominator rational. Same idea over here. Let's go ahead and multiply by the square root of 5 over the square root of 5. So we end up with negative 20 times the square root of 5 all over 5. Now we can go ahead and make sure at the end you check we can reduce that into 4 over 1, so we end up with just negative 4 times the square root of 5. Fantastic, fantastic. All right, just a few more. Want to make sure we're solid with our proportions. I would say the fastest and easiest way that I like to solve proportions is by doing some cross multiplying. So multiplying these two sets of numbers, so 5 times the quantity of 3p minus 3 would be equal to, doing a little color coordinating here, let's see, 9 times p, 9 times p. So here we go. We end up with 15 times p minus 15 equals 9 times p. I'm going to go ahead and subtract 15p from both sides. We end up with negative 15 is equal to negative 6p. Let's divide both sides of this equation by negative 6. We end up with, let's see, p equals 15 over 6, which I think reduces to 5 over 2. So 5 halves, or 2.5. That will be the value of p that makes this proportion true. So cross multiplication, take care of business from there. Last but not least, we are looking at the Pythagorean theorem that we're going to use for finding the missing side of a right triangle. Now, the Pythagorean theorem we all know and love, a squared plus b squared equals c squared. And remember that a and b represent the lengths of the two legs of the triangle, the two shorter sides, and c represents the length of the longer side. Be careful, a lot of times students assume that this is the number that we don't know, when in fact right now, we actually do know that number. C is equal to the square root of 65. So let's substitute in some numbers. I think that one leg we don't know, so we're just going to leave that as x squared plus 5 squared equals the square root of 65 squared. All right, let's see what we got going on now. So here we have x squared plus 5 squared is 25. The square root of 65 squared, by definition, is 65. All right, now it's just a pretty easy equation. Subtracting 25 from both sides, we end up with x squared equals 45. Take the square roots of both sides. Of course, we're not looking for any negative answers here because we're dealing with distance, which has to be positive. So we'll say x equals the positive square root of 45, which we can simplify into the square root of 9 times the square root of 5, which is 3 times the square root of 5. And so that is the length of our missing side right here. And so I hope that this video walkthrough helped remind you how to take care of these different sorts of problems so that you're ready to practice them in the remaining problem sets and ready to meet them head on when they come up in geometry. All right, thanks so much for watching.